Hello everyone, my name is Shreeyash Paraj and this project is called the AI-Enhanced Intrusion Detection System or AI-IDS. The goal of this project is to improve network security by using machine learning techniques to automatically detect and classify malicious network traffic. In this project, I have developed a complete intrusion detection solution using FastAPI, Python, machine learning, SQLAlchemy, MySQL, and interactive dashboard visualizations. Let me walk you through this project structure. Here we can see the project workspace inside Visual Studio Code. The docs folder contains all project documentation, including the data flow diagrams, solution architecture, and project report. The models folder stores the trained machine learning model and supporting files. The SRC folder contains the core project modules such as data preprocessing, feature engineering, model training, prediction logic, alert management, severity classification, and chart generation. The static folder contains CSS and JavaScript files used for the dashboard interface. The templates folder contains the HTML pages used by the FastAPI application. The app.py file is the main entry point of the system. Now I will briefly explain the backend implementation. The application uses FastAPI as the web framework. The machine learning model is loaded using joblib. The system connects to the database using SQLAlchemy. Whenever a network traffic scan is requested, the trained random forest model analyzes the processed traffic features and predicts whether the traffic is benign or malicious. If a threat is detected, an alert is generated and stored in the database along with information such as attack type, severity level, confidence score, source IP address, destination IP address, and detection timestamp. The system also maintains traffic logs and model performance metrics for analysis and auditing purposes. As shown in the terminal, the project code has been successfully committed and pushed to GitHub. Now I will run the application locally. The FastAPI server starts successfully and hosts the AI-enhanced intrusion detection system. Next, let us move to the dashboard. This is the main security operations dashboard of the system. At the top, we can see key performance indicators including total traffic scanned, total threats detected, safe connections, model accuracy, precision, recall, and F1 score. These metrics are generated dynamically using data stored in the database. The model currently achieves an accuracy of approximately 99.8%, demonstrating highly effective intrusion detection performance. In the Active Traffic Inspector section, the system displays real-time traffic analysis results. When I click the Scan Network Traffic button, the machine learning model processes network traffic records and classifies them as either benign or malicious. The console displays traffic details including source IP, destination IP, protocol information, and prediction results. On the right side, the Quick Threat Metrics panel provides a summary of attack categories detected by the system. These include DDoS attacks, port scan attacks, botnet activity, brute force attacks, and web attacks. The dashboard also provides visual analytics. The traffic composition chart displays the overall distribution of benign and malicious traffic. The threat incidence chart shows the occurrence of different attack categories. The threat trend chart visualizes how security events change over time. These charts help security analysts identify attack patterns and monitor network health more effectively. Below the charts, the recent security alert section displays alerts retrieved directly from the database. Each alert contains severity level, attack type, source IP address, destination IP address, confidence score, and timestamp information. Threats are automatically classified into different severity levels such as critical, high, medium, and low based on the attack type. The system architecture consists of three major layers. The presentation layer contains the dashboard and visualization interface. The application layer contains FastAPI, prediction logic, alert management, and severity classification. The data layer contains the machine learning model, processed data sets, and MySQL database. Overall, this project demonstrates how artificial intelligence and machine learning can be integrated with cybersecurity systems to improve threat detection accuracy, automate alert generation, and provide real-time security monitoring. Thank you for watching the demonstration of the AI-enhanced intrusion detection system.